Alright, number 3, a city map is placed on a coordinate grid. Post office is at 5:35, library at 15:10, fire station at 9:25. And what's the ratio of the length, that's a key word, of PF to the length of LF. So I need two different lengths. So I'm going to be using the distance formula for this. So the distance formula I have to know. And the distance formula is pretty easy to remember if you remember it's related to the slope formula. So I take the square root of, remember, y2 minus y1 for slope. So there's the y2 minus y1, and we square it and add it to what's on the bottom of our slope formula, which is our run, our x2 minus x1, and we square that. So that's my formula to remember. And I have a coordinate grid here, so I'm going to plot my point so I can see it, and I'm going to make these go by, I'll do, each one of these is worth 5, so I'll label every other one. So 10, 20, 30, and I changed my mind. I'm going to go by 5s. So I'll say that's 5, that's 10, 15, 20, and my biggest x value goes up to 15, so I'm good. Now on the y-axis it goes up to 35, so I'm going to label every other one. So that can be 10, that can be 20 right there, this one will be 30, and then up to 40. So you definitely need graph paper for this. Or that's very helpful, I think. I'm going to graph these points. So 5:35, go right 5, up 35, put a point, and I'm going to label that as P. 5:35. That's our post office, I believe, yes. And then the library is 15:10, so go right 15, up 10, and that's my L. And then go right 9 and up 25, so that's right about there, and that's going to be my F. So I'm going to label all these points. So F is 925, and my L was 1510. And I'm going to do the length for each of those. It wants P to F, so it wants from here to here. And since that's diagonally, I just can't count the boxes and say that's the distance. I have to use the distance formula. And I'm going to use from L to F, so from right there. And it wants the ratio, and that means order matters. So I have to do P of F on top, and then LF on bottom. Alright, well I'm just going to plug those numbers in. So I'm going to call this my x1, y1, x2, y2. I'm going to do the PF first. So plug it in. It's going to be 25 minus 35. And then squared plus x2 minus x1 would be 9 minus 5 squared. And that's going to give me negative 10 squared. And remember, anytime you square something, it's always going to be positive, so it doesn't matter, that's a negative 10. And then 9 minus 5 is 4. And then square it. So negative 10 squared is 100, 4 squared is 16, so that's the square root of 116. And I have a calculator, so I could say or 10.8. Alright? And now I'm going to do that same thing with my next ordered pair. So I'm going to call, I've already called F, X2, and Y2, so I could call 15 X1 and Y1 if I want, and now I'm just going to find the distance from there to there. So I'm going to plug those guys into my distance formula, and I want to still see those numbers. There we go. So again, it's going to be the square root of y2 minus y1 here would be 25 minus 10. I'm going to square that, and then plus my x2 minus x1. I use 9 for x2, 15 for x1, so it's 9 minus 15. squared. 25 minus 10 is 15, and I'm going to square it. And then 9 minus 15 is negative 6. I'm going to square it. I'm going to add those up. So 15 squared is 225, and 6 squared is 36. So 225 plus 36 gives me 261. Remember, that's still in the square root. And I can find the exact, the decimal answer, which would be about 16.2. And now I want to find the ratio of those numbers. So I can just use my calculator now and type it in. This was my PF was on top, I believe it said. Yeah, the ratio of PF to LF. So I'm going to write PF over LF. I'm going to plug in for PF, it was 10.8. For LF, it was 16.2. And if you just divide those out, you'll see you get 0.666 repeating. And 0.66 repeating is just going to be 2/3. So that would be choice A. Alright, so just a lot of work there, but not too hard of a concept, right? And that's how you do number 3.